Welcome back to the channel, everyone. In this video we're going to be doing something I've been putting off for ages, and that is taking apart the head of my mill and trying to fix the rattle in the head. Now, I bought this mill a few years ago and it had a very small rattle that I didn't notice at the time, and fast forward to today and the rattle is a lot louder, and according to Google it's most likely the nylon bushings in the head, which if left as it is can damage the shaft. So it's time to take it apart and try and fix the problem. Before we get started taking it apart, let me just show you what I mean. That rattle that comes and goes, that's the problem. If you're wondering, I definitely switched the power off. So I've got the bottom cover off. Probably have to pull the bearing off and use the screws to tighten the variable speed assembly so that I can take the motor off. So I've got the bolts in and I can feel that the belt is now slack, which is good. So I should be able to remove the motor. I really struggled getting this motor off. This isn't a 1 or 2 horsepower motor, this is a 5 horsepower motor, and I was standing in a pretty awkward position. So I finally managed to get the motor and head off. I had to tilt the head and use a pulley to lift the motor. It's a lot heavier than it looks. So to get the motor off, I actually had to remove the bottom variable speed disc. I basically compressed it with these bolts and then removed the circlip, and then it was able to slide off the shaft, and I was able to pull the motor off without actually having to get the belt off the variable speed pulleys, which was practically impossible. I tried. So here is the top housing. It's also really heavy, but it was a lot easier to get off than the motor, as you've got all these handhold grabs. So once I've taken it apart, I found that the bearing for the spindle bearing cap is making a little bit of a noise. I suspect it's got a bit of, somehow grit got into it, so I'm gonna have to change that bearing out. I can't get it out, so I've ordered a new bearing puller off eBay. The belt looks in really good condition. This mill was made in 1996, but looking at this belt you wouldn't know. So I'll probably leave the belt, considering they cost about 150 bucks here in Australia. So these are the plastic bushings that have caused all these problems. It's a fairly common problem on all these mills. They're bad on the spindle shaft and on the motor shaft, so I'm going to have to make replacements, since pretty much no spare parts exist for this mill. I've tried emailing the manufacturer, I've tried emailing different places around the world, I've tried calling different places, and well, nobody has parts for this mill. So I've ordered the plastic off eBay and I'm going to try and make those bushings myself. Hopefully I'll succeed. If I don't, I'm going to convert the head to a variable speed drive with fixed pulleys. Anyway, I'm also going to replace the keyway, since it's a little bit undersized now. It might be that it was originally like that from factory, but I suspect it wasn't. And I'm going to continue disassembling it. Since I found one bad bearing, I might as well disassemble the whole head and repack the ball gears with grease and check the other bearings. So let's keep going. Hopefully the camera picks it up, but you can see shiny spots on the shaft from the bushing constantly rocking. This nut was completely loose. So I pulled out the high and low lever. So I was struggling to get the ball gear off, and then I noticed that they kindly provided us with some threaded holes to jack it off. Awesome. It was about at this point that I really got into the rebuild, and boy did I wish I had some sort of hydraulic press. I needed lots of different bearing pullers and drivers to complete this rebuild, a lot of which would have been completely unnecessary and much less painful if I had some sort of hydraulic press. Also, if you're going to attempt a similar rebuild, I highly recommend the videos on rebuilding the Bridgeport mill by H&W Machine Repair. Although the Taiwanese clones have some differences, they are mostly the same. Generally, they're fairly easy to rebuild. Just use some common sense, like not hammering on the ball bearing balls, and you should be fine. Most bearings are just pushed all the way until they bottom out. So down the rabbit hole we go. I ended up taking off the top heart casting and the spindle bearings out because I couldn't really clean out all the gunk that was in there. There was quite a bit of chips in there and things like that, which I've cleaned out now. The only thing I can't understand is how the spindle bearings were actually lubricated, because one oil cup went in here, the oil went in here, and the other oil cup, which I've pulled out, basically was like that and dripped the oil on those gears. So I can't really find how the oil made it to the spindle bearings, and looking at the spindle bearings, they were not quite lubricated well. I'll show you those in a minute. Not sure if the camera picks that up. You can see there's like a haze on the balls, and it's not oil or anything, it's just wear, I guess. I mean, they spin fine, but I might just change them out just to be sure. I don't have a press, so this is my redneck solution for removing the spindle bearings. Here I've just sprayed the shaft with some inox and wrapped it up in some Glad wrap to go in the freezer. These are some nice Japanese P4 bearings that I picked up from eBay. After leaving the spindle shaft in the freezer overnight, it's time to install the new bearings. For some reason this mill had a bolt through the quill, and that's why I had to disassemble this part of the mill so I could pull out the spindle. So I've made some replacement bushes. I'm going to make a separate video on how I made these, but it's not as difficult as I thought it was. So I'm just going to get that screwed together and then we can press this back on. Getting this bearing out of this bearing cap has proven quite troublesome. Now I've tried those bearing pullers with the two jaws that go on the outside and underneath the bearing. Unfortunately, what's the problem with this is that the bearing is seated quite deeply in this cup, and there's very little room between the bearing and the cap to actually get thick enough jaws underneath to get a strong enough grip to pull it out. And what's ended up in the past is that those jaws have just bent. So I've gotten this type of bearing puller off eBay. Hopefully it'll do the trick, since there's a lot more surface area that's gripping. So hopefully this one will be strong enough to get this bearing out of the cap. So I finally managed to pull the bearing out. Heat was the key. I didn't want to use a torch since that would probably get it too hot and this lead paint here would start coming off, which I didn't want to breathe the fumes in. Anyway, the bearing is completely toast. I think that's grease and rust and other stuff. I don't know what it is. And I've managed to bend the bearing puller, which is not unexpected considering how difficult it was to pull out. I just started disassembling the variable speed assembly head. This is the brake, and your belt goes over here, and this is the variable speed disc. Now in H&W Machinery's YouTube videos, he just got 2 pry bars and he just levered this bottom part off, which is what I needed to get off to get access to the bearing. I put my hydraulic puller legs on here and tried to pull it off, and it was not going anywhere, and I was afraid that this is cast aluminium and I was going to damage it. So what worked for me was to get the gear puller and push the middle shaft out, and once I got the middle shaft out, let me just get this part off and show you. So once this was pushed out, I was left with it assembled like so, and then I was quite easily able to get this bottom part off with a gear puller. Now the reason for that is this is an interference fit, and then this fits over this part, and I'm pretty sure that when this is pushed in, this will expand a little bit, and it really makes it very tight, just due to metal expanding. So if you're going to do the same thing with a gear puller, if you've got a press, it's probably pretty easy, but if you're going to do this sort of thing with a gear puller, then it's much easier to push the shaft out first, because you're pulling on cast iron and this is very unlikely to break. And once the shaft is out, I think this diameter shrinks a little bit from the interference fit and it comes out a lot easier. So that's the way that I did it. So what I'm trying to do is just push out this internal part out the bottom here. So it's coming out. I had a hard time getting the high and low lever in, but I had to raise the head up vertically and really push down on it to get it in. Well, the mill is finally back together and it's running beautifully. So let me just show you how it sounds like now. It's very quiet compared to what it was before. There's no more rattles or any other noises. And I've already done a few projects on it and it runs much better. I used to have a chatter problem with deeper cuts and now it's all gone. So I guess the spindle bearings were on the way out. And as you can see, I've added a wheel and I've made a quick change handle for the quill, and that'll be a future video. And let me just pan the camera down so I can show you what else I've done. As you can see, I've added a chip shield from plexiglass, and that works fantastic from stopping all the chips from flying all over the shop. Anyway, I hope you enjoyed the video and I'll see you next time.